Now, I think one of the easiest things to talk about as far as counting is to show you an example. This morning, what is this, 12 hours? This morning I thought I would count something real quick. I counted 21 dress shirts. Yeah, and I had 32 ties. How many different combinations am I able to create out of those two sets? That's all it is. So if you think about it, if you take 21 times 32,
You never want to turn in this homework, like the two, like 11.3, 11.4.
no.
So it's your birthday, you have to let it
So we
Your birthday's
have
this
16
weekend.
students in this room at this moment and 34 seats.
That's different. That's a little bit different. We'll talk about that, but that's a little bit different. So if I'm just talking about pure different combinations of ways that I can choose a dress shirt and ways that I can choose a tie, what I counted in my closet this morning was 21 dress shirts and 32 ties. I don't know, I might have miscounted here or there, but if you put that together, that means there are theoretically 672 different combinations between those shirts and ties.
Probably not every time goes together.
Does it matter to me though?
No.
And then have I ever looked like I really cared if something matched or not?
Did you actually count like these are actual numbers?
Yeah.
I feel like you show up one
You
day
didn't
and
just make
have
these
like
up?
a
No.
bright red shirt.
No.
with a-
So if you start thinking about this and you go through it, there's 180 school days, give or take.
Left.
Well, total, and that's if I wore a shirt and tie every day. I'm sorry. Let's divide this by 180. Oops.
Why are we doing that?
For school years. So if I take 672.
100 days per year is how long you work.
Have you seen it in the office?
So basically, if I wore a dress shirt and a tie every single day for every day of the school year, which you know I'm pretty decent about, it's 3 to 4 days a week,
You'd have almost 4 different options.
I'd have almost 4 school years worth of combinations without repeating them.
Can you just do that?
There's too many ties.
Seriously, if you start thinking about it. So if you think about the amount of clothes that you have, if you think about the amount of clothes you have as far as shirts, t-shirts, polo shirts, and whatnot, you start really going through all the different things that you wear, you're going to have years and years worth of clothing if you start to really think about it. If you have, I mean, for girls it's a little bit different because you've got dresses and skirts and pants and leggings and things and whatever, overalls, whatever. I don't know, do you still wear overalls? I don't know. They were really big when I was in high school. But if you, shut up. Wasn't that long ago? Yes. So if you start really going through it, you're multiplying all the different possibilities all the way straight through. This is fundamental counting principles. It also works with deli sandwiches. Think about Subway. Actually, go to the one I have about Subway. Oops, I don't. Subway. If I'm not mistaken, at Subway there are, let's say that there are 16 different meats. No, there's not 16.
There's like 6 different breads.
All right. So first thing you pick at Subway is bread, right?
There's probably 12 different breads.
I think there's.
Hey, someone with the Google, find out how many different breads there are at Subway. We'll say that there's 6. Meats, you've got ham, turkey, salami, pepperoni. What? That's not meat, doofus.
Bacon.
That's cheese. Bacon, meatballs, chicken,
Don't they have like
tuna.
Vegan. Let's go with 14.
There's 6.
Chicken salad.
There's 6 different kinds of
Vegan.
bread.
How many different meats are there? I'm up to 9. I'm gonna guess 9.
Vegan.
I feel like there's
Murphy.
I'm gonna guess 12.
Did you say
6 meats?
6 breads.
Okay.
Did you say roast beef?
No, I didn't. So we'll say 10. And then you start thinking about cheeses. How many cheeses do they have?
26.
Like 4.
Okay, what's
American.
this? 1, 2, 3, 4, 5, 6, 7,
8.
There's 8 cheeses,
Jack.
There's Italy.
and then you have
There's 14
Toasted or
meats.
non-toasted?
14 meats.
Yes.
Yeah.
Well, like,
They're probably
I
like,
have guessed every single
I mean,
one right so far.
some places have.
Now, if you start thinking about toppings, you've got
jalapenos.
hold on. We got lettuce, tomato. We'll just say that there's a dozen. I don't know. There's probably more, but we'll just say a dozen toppings.
I'd say
14,
18.
Okay, this is making me laugh.
14.
Well, just
And then
14.
at the Murphy sub shop. At the Murphy sub shop, there's only 12 of them.
Why?
Then you have
toasted or non-toasted.
yeah. So you have 2 choices there: toast, non-toast, whatever. Let's just say, just going through this.
Then you don't.
If you start thinking, well, for
8,064.
how many?
8,064.
8,064 sandwiches. Now, track. What's 8,064 divided by 365?
22.09.
So basically, you could theoretically have a different sandwich at Subway every day for the next 22 years.
But if you divide it by 3 for 3 meals,
Wait,
it'd last
if you
7
put all the numbers correctly, you can have a lot more.
You could. So that's the idea when you're talking about.
Then there's
Well, hold on. Let me get into this here. That's where the whole idea of counting principles comes into play. You start to think about choices, and really, you probably never realize how many choices there really are. There's a lot. There's a lot more than you ever thought of. I never in a million years thought there were so many choices until we built a house. We built a house, you had to choose everything, and you had lists of everything to choose from. Siding, what types of siding? Colors, what color of siding? Shingles, what type of shingles? Color, what color of shingles? Windows, doors, door colors, door styles, door handles, carpet, hardwood, tile, whatever. And you start compounding it through, the amount of choices it gets to be, it's just astronomical, okay? And you don't think that it's that much really there until you really, really get into it. And so it gets to be, it can be overwhelming quickly. So what happens here is when you're talking about what's called the, don't write all this out. When we're talking about what's called the fundamental counting principle. The fundamental counting principle basically says, if one event can occur so many different ways, and another event can occur in so many other ways, all you're doing is just multiplying those events, those possible events together. Goes back to the idea of shirts and ties. 32 shirts, or sorry, 21 shirts, 32 ties. If I multiply those together, I had 600 some odd different shirt tie combinations. Excuse me. Excuse me. Oh, all right. Excuse me.
When you weren't here on Monday, it was so quiet.
Police use photographs of various facial features to help witnesses identify suspects, like Kaiser Soze. One basic identification kit contains 195 different hairlines, 99 eyes and eyebrows, 89 noses, 105 mouths, 74 chins and cheeks. So basically, you're putting together, gosh, what was the name of that game? Yeah, I want to say it's, yeah. Potato Head. Yes, you're right. This is Mr. Potato Head. It is kind of, yes, you're right. This is Mr. Potato Head on a grand scale, okay? And you start thinking about police artists would sketch. Nowadays, it's all computerized, where you're looking at computer bank of images, and you're trying to remember, what did their hairline look like? Oh, what did their eyes look like? What did their nose look like? What did their facial features? And you're trying to pick those things together. And you're trying to bring this all together. So if you go through it, it's a matter of just really 195, 99, 89, 105, and 74. Trap, you've already pressed the buttons, haven't you?
That is a really
Shouldn't there
big
be
difference.
Shouldn't there be 299?
Oh, what it is, it's the eyes and air, and so it's this with the eyebrows.
But what if you have like one pair of eyes with a different pair of eyebrows?
I don't know.
And then the
So it should be
something's
tied.
went wrong. I got like this desk.
What if the bad guy has Maddie's eyes and my eyebrows? How would you know who the bad guy is? Like, how
What
could
if you
you
have
be
two
able to
different color
identify?
eyes? A blue eye and then a like.
Did you say 3 color eyes?
I said 2.
I swear you said 3 color eyes.
Wait,
You
said
said-
2.
I swear you said.
He said 2.
Okay. All right. Fine. Let's go with it. We'll go with your argument and say that there are 99 eyes, 99 eyebrows, 89 noses. One of them could be a red one.
to the 10. What does that tell you?
And then
Is it really a decimal?
Yes,
Only
it's
nine.
You put that in the calculator. What did you said?
She said she got a decimal.
Well, I
but
know it is a
let's,
decimal with it needs
It's
a.
like
So that's
1.31648
usually decided to-
8
No.
to the 12th power.
So what was it? 1 point. This is wrong.
Oh, I didn't add the extra 7.
32164.
8678 times 10 to the 12th power.
Okay. That means I have. Well, that means I need to move that decimal place over how many times?
12.
12. Okay. So if we move this over, 1 little, 2 little, 3 little spots, 4 little, 6 little spots, 7 little, 8 little, 9 little spots,
That's wrong.
10, 11, 12.
The answer's
It's wrong.
I got
Yeah.
a different one.
What'd you get?
9.78.
Whoa, whoa, whoa! What is it?
9.78020022.
I didn't have 274s.
To the 13th?
I didn't have 274s.
All right. Anyway, so let's count again. 1. Come on. 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots. Sawyer?
All right, I'm
10, 11, 12, 13.
Oh, come
Good
on.
job, Sawyer.
All right, so let's see. 100, 1,000, million,
Trillion.
billion,
Billion. That's
trillion. 97 trillion, 802 billion, 2,200,000 possible different facial combinations.
That's like more than like 10 times the amount of people who live in America. That's definitely right.
So what you're saying is that there's not 97 trillion people in America, there's 9 trillion people in America.
That's okay. That's more than a lot of times. There's like
Good
There's only like
Harris.
6.2 billion people on the
Tell me,
planet.
can you actually?
Anyway,
I thought that
so,
was in, wait, how many people are in America?
There's 6.2 billion people on the
and here's the
planet.
I
deal.
thought that was in America.
Now,
I thought there was a few billion people in America.
There are.
I think like
Anyway.
2 billion.
so as you go back into the idea of this, if you ever get mugged,
You're
so, no, I'm serious, and I don't mean to turn this conversation sour, but if you ever get mugged, try to know a little bit of what they look like, because the minute you know and you remember what you can recall what they look like, instead of having 98, 89 noses, you know what it looks like. There's one, and it cuts it down. So if you know just 2 of those things, the eyes and the nose. Let's say you know the eyes. You knew the eyes, the eyebrows, and the nose. Make these all ones. Now multiply it out. When you multiply all that out, you're going to get it's still a really big number, but you have a better chance.
Oh, instead of
One
1
of
and
them.
9 it's like 1 and
That's why I say you
872.
gotta have cameras.
Right. So if you know all those things, it's 1 out of 827,000.
Yeah.
How is there 0.347 of a person?
Wait, what?
It says there's 7.347 billion people.
Billion. 7.34
Oh!
billion.
Oh, that makes more sense.
So that means it's. Are you
I
sure?
get it now.
Are you sure? I'm worried.
get it.
Worried. So what does 7.34 billion actually stand for?
It's 7 billion, like 347 million.
Okay. I was making sure. Are you reading what it is? You are. aren't you?
No, I'm not. Because then on the other side it says 7.5 billion.
License plates. You can do this with like license plates.
Oh,
Okay.
Oh boy.
Now, as you know, the state of Illinois has 1,000 different license plates. It's one of the weird states that they. Oh jeez. One of the weird things that they do in the state of Illinois is that they use it to help make money. That's why there are Cubs license plates, Bears license plates, Sox, Blackhawks, whatever. There are educational ones, golf ones. If you've ever looked at Cyber Drive, Illinois, you can easily put in and look at different plates of vanity or personal and so on and whatever. Well, what you can do here is the different combinations that are available depend upon what the parameters are for the digits. Now, the example that this book uses is license plates out of New York. New York uses 3 digits, 3 letters for a standardized license plate that they just automatically generate for you. Not being a personalized license plate, not being a vanity license plate.
Would it be like 10 times 10 times 10 times 26 times 26?
Exactly. That's exactly what it is. Now, what happens here is, I know most of you guys are starting to get the idea of driving cars and license plates. Do you know the difference between vanity and personal? Okay. Personal license plates may have letters and numbers. Vanity are just numbers alone or just letters alone. No combination. You pay more for those. So if you think about if you have 3 numbers and 3 letters, how many digits are there?
6.
I think you're wrong. How many digits are there for numbers?
10.
10.
That's hard
So
to
if you
know.
chose,
Yeah.
you have 10 possible for the first number, which means there are 10 possible for the second number, which means there are 10 possible for the third number, and like you said, switching to letters, how many letters are there?
68.
You start in your head.
Braden said laughing face, laughing face, laughing face. What are you guys doing today in there?
Math.
Wait,
Tell him we started to
Say that.
hard chapter.
Say that again, Murphy.
Impossible.
That again, Murphy.
Say we're doing math.
We're doing math.
You say we're doing that?
Now, if you multiply that out, you have 10, 10, 10, 26, 26, 26. That gives you your total combinations.
1000 times 26 cubed.
Correct. Now, what happens if you can't repeat a number? If you have 10 to start with, how many are left in the next one? And then how many? Exactly. So if you can't repeat them, so this is with repetition. This non-repeating, there are 10 to choose from, 9 to choose from, 8 to choose from, then 26, 25, and 24.
And then it also goes with like the state license plate too. So then like it can be like the same. Can it be like the same exact combination, but then like Illinois?
Yeah, each state's a little bit different. The book just used one out of New York. I believe the state of Illinois, for passenger cars, passenger cars have letters first and then numbers. Passenger cars, I believe, can have for random, when they do the random, I think they also go 3 and 3. Sometimes you'll have 1 letter and numbers and spaces. Nowadays, I've noticed this when my wife bought a new car a couple weeks ago. The temporary plate that we got had 2 letters and then 4 numbers. Whereas a lot of times it used to be 3 and 3 or 1 and 5 and whatnot. So that if you really start thinking about it, you're never really going to run out of license plates because you can always switch up a parameter and change a certain thing. You can repeat letters, you can not repeat letters, you can cycle things through. There are so many different combinations of these things that you can get to. And then you get into all the different personalized plates. You get into the personalized plates, there are so much. So each state is a little bit different. I don't know if you've ever noticed this also, cars start with numbers, start with letters and then go to numbers. Trucks start with numbers and then they end with letters. They're flipped. Did you notice that? Ever notice that?
So
No.
does that mean
Just
that
the
like,
numbers.
does that mean that you could do like 36 to the 6th power? Because like you could do a letter or a number.
That in Illinois you can't intermingle numbers and letters. I think they do that in California because you get more combinations, and that's a good question. Do you guys hear what she was saying? If I'm not mistaken, in California the license plates can intermingle between numbers and letters. And if you think about that, there are 36, 36, 36, 30 for all 6 spots or 7 spots that there could be. So you've got so many more license plates. Plus California has so many more people, so that's probably why they do that. Okay. Whereas Illinois, it still splits things out. Each state is different. But this is the idea. repetition, non-repetition. Does that make sense about that? Kind of leads you into how the idea works for lottery numbers. Lottery numbers aren't repeated when they're doing the Powerball, are they? Well, Powerball games start with 54 numbers. If one comes out, how many are left? 53. 52, 51, and then 50. And those are the first 5. And then the Powerball number is its own hopper. You guys have seen this before, right?
Yeah.
Is its own hopper, which there's another 54 of them. So the different combinations of the different, excuse me, the total possible outcomes that you could get by multiplying these things through is a ginormously large number, like stupid big. I multiplied this out the other day, and I think it was,
Oh my god.
it's like
2 number.
2.05 times 10 to the 10.
10 to the 10th, 2.05, 10 to the 10th. Sorry, so 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. $20 billion. All right, so there's approximately a little over 20 billion different combinations of Powerball numbers. And how many of those are out there that are winning tickets? One.
So you're not gonna.
You're not going to win. And that goes with the whole idea that I used to have this really great Powerball simulator that would run this at an astronomically large, fast pace. I've been running this one since 12th hour yesterday, right after school, and in less than 24 hours, I have played Powerball for 507 years. This is automatically generating numbers versus the Powerball numbers versus my draw. I'm spending so much money per ticket, and I'm trying to return on investment some winnings. If you look at it, I have only won $100 twice in the past 513 years. Success, yes. I have lost, let's see, where is it? I have spent, in 520 years almost, $162,000, and I have only won $24,000.
That's pretty good.
I am losing 85% of all the money that I'm putting in. So it's basically, sorry, your birthday's coming up. Can I have 15 cents, please? Can I have 15 cents, please?
It's under my locker, but no.
Can I have 15 cents, please?
Who carries around?
Yeah, I got this thing.
You got 15 cents?
Yeah, here's a pencil, give me $1.
And that's what it is. I gave him $1, he gave me 15 cents.
Hey, a pencil,
Whoa,
free
whoa,
value.
wait.
Woo-hoo!
That
This-
works. I could have just
Yes.
handed you my pencil.
like, wait, I got highlighters. But that's kind of what's happening when you're playing the lottery. You're not going to win.
I mean, there's
Somebody
always
has
that one
it.
person that wins.
I'm fine,
Somebody
don't
has
need notes.
True, but you're not going to win.
I mean, how can you know for sure?
You don't. And that's the idea.
You never know, so they keep playing. There's always that chance.
That is the reason that people lose money.
You could always be that one person.
True, but
Because, I mean, that one person is the one person who never thought that they would win.
I agree. But the probabilities of it, as you get into it, the idea that you could actually do it, you have a better chance of being mauled by a tiger while living in DeKalb. Or being struck by lightning twice. I just got hungry from talking about all that sandwiches. If you look at the odds, if you Google the probability of being struck by lightning, I believe it's like 1 in a million or something. Like it's,
That's it.
Well,
That's
shut
like
my
more
light.
than a trillion.
the probability of being struck by lightning is
It's 1 in 700,000.
okay. So 1 in 700,000 being struck by
Oh,
lightning.
wait, it's 1 in 3,000. The odds of being struck in your lifetime is 1 in 3,000.
I'm not going to That is an awful waste of resources.
Being struck by lightning.
But in the U.S., it's 1 in 700,000. But
Okay,
just
well-
the odds is 1 in 3,000.
Roy Sullivan was hit by lightning on 7 different occasions.
So really,
Survived all of
think
them.
about it. Being struck by lightning is a 1 in 700,000 chance.
That's
If you're
Roy. That's Roy.
That's just in the U.S.
That's just, well, we live in the U.S. We'll use that statistic.
Down to 70,000.
The probability of winning, of picking of the correct numbers in the Powerball is 1 in 20 billion.
So you could get struck by lightning.
He's a park ranger. That's Roy Sullivan.
Good old Roy. So he's a park ranger, means he has to have a hat.
He was a park ranger in Virginia. Why did he give him a top hat?
Because he's a park ranger.
That's a park ranger.
That's not a top.
That's like an 80.
Only you can prevent forest fires. What's his name? Smokey the Bear. He wears a hat like that.
He does.
Not Yogi Bear. Hey, boo. Who's gonna go get a ticket in Quebec?
We're Smokey Bear.
We'll look at my
All right. How many different ways can you arrange the letters A, B, and C?
Lots. Probably
5.
9. I'd say 9.
Nine.
Like ABC,
Smoky.
ABC,
It's 9.
EAC.
No, it's not. It's 3 times 3 times 3.
Which is
How many letters are there?
3
27.
times 3 is 27.
This is Smokey the Bear.
3 times 3 times 3.
So
27.
if I put, you have only 3 letters, right? Which means that A can be in the first spot,
Smokey the Bear.
and B would be in the second, C is in the third. Or
There's 1.
there's 1,
2.
there's 2. Okay. Now we go back to normal. Now A can be in the middle spot.
Someone should really make sure he's not there.
Hey, you can arrange it more. You could go B, C, A,
Isn't that the same
That is-
thing as
but it's not the same direction.
what's happening here is what's called a permutation. If I'm arranging objects in a specific order, where the order matters in the way that you can arrange the letters A, B, and C, it's not that you guys are thinking it's 3, 3, and 3. It's not that A can be represented 3 times. There's only 3 letters. It's like, how many ways can 3 people be first, second, and third? Well, you can be first, second, or third. You can be second, third, someone else's first, and you rotate through that. So what's happening here is,
The first one.
what's happening here is that you've got your
Something same, but it's
A, B, and C, A, C, and B. What is it? B, A, C,
BCA.
B, C, A.
You already have that one.
Oh, I was starting over. Sorry, I was starting over with this, just to go through the whole thing. C, A, B. So you get those 6. What's happening there is the order mattered. It's kind of like the idea of the license plates, non-repetition. 3 spots for the first one. A can go in one of 3 spots. Once A is placed, how many spots are left over for the other 2? 2. And then how many spots are left over for the third one? 1. So if you have 3 objects, you have 3 objects. This is 3, 2, 1. That's what a permutation is. 3 spots for the first one. That one's taken up. There's 2 spots for the next one.
He sent a
That's-
picture of his driver's license.
Congrats.
That's
And then you have the first one. Okay, tell them the homework's still due tomorrow. Now, as you get into this, do you know what that? You know what also that represents?
Emma,
What?
do you have to take a test?
Nope. Do you know what this means?
No.
Usually countdown for something.
Blast off.
It's just like
You know what that represents? Anybody? Yeah. Do you know what that's called? If not, 3. That was great. It's not 3. That was awful. You're right. It's called. What is it called? Yeah. I just drew brain fart. What is it called
You
again?
need to try this again.
Factorial. You guys ever seen that before? I am making up words. It's like exponentiating. I'm exponentiating your knowledge base of made up words. All right.
Just put that on
So,
one more second.
Factorial is
Okay.
3 exclamation points. That's what that means. 3, 2, 1. I always love scaring people. I do it every year.
Earlier this year, you got the whole class, you were like talking slowly and you just jumped around.
Wait, you can't see
I do that a lot because it's fun. So let's look at this. 12 skiers are competing in the final round of the Olympic freestyle skiing aerial competition. Woo! Flying and jumping and doing all this stuff. How many different ways can the skiers finish the competition, assuming that there are no ties?
479 million.
Well,
1,000.
there are 12 skiers, so that is, if there's 12 of them, you've got 12 people who can finish first. 11, 10, 9, oops, can't write. Hey, did you know there's a button on the calculator? That was under math, isn't it?
Oh, so you can get it through alpha window 9 now. Yeah, it's there.
Oh.
It's quicker to do alpha window.
Is it? Alright, so what was it, alpha?
Window.
Thanks. So 12 people skiing in the competition. There are
479 million.
Oh, that's why you.
there are 479 million different ways 12 people can finish a skiing competition.
Whoa, really?
Yeah. How many people run on a track meet when you for the 1600? How many people was it? 8?
Yeah, or like 8
All right. So if you've got 12 people running the 1600, there are 479 million different ways you guys can finish. But when you finish first, that means that takes away the other ones. Just divide that by 12, and there's the answer. Say, screw you, the rest of you losers. Slowpokes. Right? That's the idea.
Can
Okay.
you just do 11?
Yeah, I'm over it now.
I'm going to stop there, and we'll get into more of the idea of how the permutation stuff works tomorrow. I don't think I need to get too much further. Let's see.
Let's do number 7.
I'm gonna see if it's gonna
Let me back this up. So in 12.1,
see it stays on your head. My head's too big.
It's not even anywhere near my birthday.
You need to tell him I'm on
I'll
it.
wear it.
I'll send him this. Page 705, just leave to send that.
All of it.
Or just put 12.1.
Two,
Did you put a band-aid on this?
Ooh.
Why are you questioning the birthday crown? Stop, Sawyer. It's not anywhere close to my birthday.
yeah, we'll stop there, and then we'll finish the rest of it up
Maddie,
tomorrow.
when's your birthday?
There's only the
you're
permutation
old.
part and distinguishable outcomes. That'll take about 10 minutes to talk about tomorrow, and then I've got another maybe 10 problems you guys can finish out. I figured that's a good place to stop on this one instead of trying to power through all of it. Oakley,
You can have it.